Hello and welcome. This is Dr. Victor. In this video, I am going to talk about a very useful programming construct called the Accumulator Pattern. I'll explain what it is, its variations, and show you some code examples of these variations. Let's begin. When writing programming code, we often come across with similar tasks, like to get some input from the user, process the input, and to show something, or to open a file, process the content, and show some information about that file. To complete these tasks, we have some standard ways to do so. For example, we set up a particular set of variables, use a particular loop, and output things in a particular format. I call these programming constructs because they have their own structures and allow you to adapt them to complete tasks. And once you are familiar with these constructs, you can get those tasks done very easily and focus your effort in developing the more complex part of the program. The accumulator pattern I'm talking about in this video is a very useful construct. Its primary use is to add up a bunch of stuff by storing them in a single variable. But with some tweaking, you can use it to calculate things, count things, and even find things. Let's begin with the basic use of the accumulator pattern and the key components in this pattern. Here in the screen, we have a list of numbers. We want to calculate the total of all the items. To do so, we create a variable called the total. And we start from a value. Let's say we start with the number 0. This is what I call the accumulator variable, the first key component in this pattern. Next, we need to go through the list item by item so that we can get their values and add things up together. This is done using a loop. So for example, I can use a for loop here. I'm going to use the standard way of using a for loop in Python. I need to go through the entire list. So to do that, I'm going to introduce a new function provided by Python called range, which allows us to generate a sequence of numbers that can be used as the index of accessing our list of numbers. So here I need to know the length of the list. So I'm going to use length, which tells me what is the size of my list. Like this. Now, this loop is actually our second key component of the pattern. The important bit here is while I'm going through the list, I accumulate the item values to this variable. So this is going to look like this. So I'm going to through the loop, going through the list in the loop, and I'm going to add things to the total. Total equals to the original value of total and plus the current item that I'm visiting or looking at. All right. And this is actually the third key component of the pattern. So as you can imagine, by the time the loop finishes, this variable is going to have the total of all the items. So we can take a look at this by printing out the content stored in the total accumulator variable. So let's give it a run. Oops, I think I'm missing. So I'm missing these indexing the item that I want to look at. So let's run again. You can see that it's going to tell me the total of that, 508. Now, once we have that, we can calculate the average of all of the numbers by dividing this total with the number of the items of the list. Here, we're going to use a secondary accumulator pattern to find the size of the list instead of using the length function. So to do so, I'm going to create another accumulator pattern. Let's say count. Again, we will begin with a number. So here we're going to use 0 because when we begin, we do not have any counting of the number of my items in the list. So next, I'm going to use the loop. We can use the same loop. This is our second key component. And we're going to add a 1 each time we see or visit an item in the list. So I'm going to say equals to +1. Right. So once we've done that, as we can imagine, the count is going to store, this accumulator variable is going to store the total number of items that our for loop has visited. So to show you that, we're gonna print one more thing, which is the count. Right. So let's give it a run. So as you can see, we have one more thing being printed out, and this is actually the number of items in this list. So 12 of them. Now, once we have that, of course, we can calculate the average, which is total divided by count. Now, to make things a little bit nicer, we're gonna type a little bit like, say, the total is. So we know that what this number means. So I'm gonna, and also this number, say, say number of items is, and last but not least, we will say the average is. There we go. So now let's give it a run one more time. You get things are looking a little bit better with the total 508, number of items 12, average is 42.3333 something like this. But that's more. What if I only want to count the items in the list that fits a certain criterion? Say, for example, to count the number of items that are multiples of 4. Then we can set up some checking using an if statement with the accumulator pattern. So I'm gonna keep this calculation on average, and I'm going to count the number of multiples. So to do that, I don't really need the total. Let's get rid of the total here. And let's get rid of all this. Okay, and we're going to keep to this count, but let's change its name to something like count of multiples. Count of 4 multiples. How about that? Okay. Now here I cannot just simply add things together because, as you know, then it's going to give me 12. Instead, I only want to know the number of items in this list that there are multiples of 4. So to do that, I'm going to add my if statement here. So how do I know that a certain number is actually a multiple of 4? So to do that, I'm going to use an operator called modulus. So this is how it works. So I'm going to look at my item, so list of numbers at position I or index I. This is modulus, and I'm going to put 4 here. What modulus does is it will perform the division, and then it's going to tell me the remainder of the division, right? So if the number that I'm dividing is actually a multiple of 4, then of course there's no remainder. That means that if the remainder or the returned value of the modulus is 0, it means that this number is actually a multiple of 4, right? So with that, I'm going to increment this by 1 because now I have found one multiple of 4. Of course, I'm gonna name it so that this actually matches with my accumulator variable. So 4 multiples. Right. So as we expect, by the time that our for loop has finishes, it has gone through all of the items in the list, and at the same time kind of hand select the multiples of 4, and if that's the case, we're going to add things together. So let's just print this result out. So say number of multiples of 4, and we're going to print our result over here. Okay, so let's give a run, and we can see that the answer is 3, and we can double check here. So we have this item 4, which is multiple of 4. 44 multiple of 4, 8 is also multiple of 4, but the rest of the items are not multiples of 4. Right? So we get the correct answer here. So this is another variation of using the accumulator pattern to kind of like select or filter things out. Lastly, I want to show you two more variations of the accumulator pattern. Let's say I want to locate a certain item in the list and figure out where in the list it is. So instead of adding things up, we're going to use the accumulator variable to keep track of the index. Typically, we start our accumulator pattern in this case with the index -1. So let's get rid of these printing, let's get rid of the checking and also the changing of the accumulator pattern, and we start from the beginning. So again, we have the list. Next we have this, and let's call it tracked index, right? So we are going to begin that with -1. What -1 basically means is that we haven't found any of the items yet. So, but we are going to find something. Now, of course, we need to look. We need to know what we are looking for. Let's say we are going to look for a certain number. So we are going to set it as a variable. So let's call it searched item, right? And let's say we are looking for the number 59. So 59, this is what we are looking for. Now the next step is I'm going to do this, use the second key component of the accumulator pattern. So here I'm going to do something very similar for from our previous variation, but instead we are not going to count the number of, say, multiples of 4. We're just going to keep track of where we can find the number 59. So as we go through the list, we're going to say if list of numbers of the current value of the current index is equal to what we are looking for. So search item. So if that is the case, then this is what we find. And then we're going to update my tracked index to the current I, which is actually the index or the position in the list that has a matching value with our searched item. Now, this is actually all we need to do in the accumulator pattern in this variation, because by the time our for loop has ended or finished, then the tracked index is going to store the location of the item that is a match. So we can do that. So let's say the searched item is at, and then we're going to print the tracked index over here. All right. So let's give it a run. So you see that it is telling us it's at 7. What does 7 mean? So we remember that in arrays or lists, the index of the first item is not 1. It is actually 0. So it is 0, 1, 2, 3, 4, 5, 6, 7. Okay. So this is the 7th or index 7, which is 59, what we are looking for. Now let's say I'm looking for something else. I'm looking for something that doesn't exist in the list. Let's say I'm looking for 100. Right? So let's give it a run again. And as you can see that the tracked index was never updated. So it remains at -1. And this is very useful because we can now use this value to see whether this item actually exists in the list or not. So to do that, we can say if tracked index is equal to -1, it means that it has never been updated within the for loop. So we can say that print item not found. Otherwise, we are going to say what we are supposed to be saying, that is where the item is. So here we are looking for the item 100. So of course it is item not found because 100 does not exist in our list of number. However, if we are saying now we are looking for 44, so we can see that it's going to tell us the answer, which is at index number 3, the 4th item in our list. Right. Now, keeping track of a value or an item here is very useful. But we can actually do a little bit more, which is the last variation I want to show you today in this video, which is, say, if I'm looking for a value that is, say, the smallest within this list. So how can I do that? So in order to do that, we don't really need to search item anymore because we are not looking for any particular item. We are looking for the smallest value. So we can use the same accumulator variable, tracked index, to remember where is the smallest value currently. So currently, when we begin, we don't know where it is, so we use -1. But we need to introduce one more accumulator variable here to help us to remember what is the smallest value we have seen so far. So let's call it smallest item over here. Now we also need to set it with as a particular value to begin with. When we are looking for the smallest value, we are going to start with a really big value. The reason why is that as we go through the list, we're going to find the winner. You know, like every time we find an item, we look at an item, we find a winner that actually is smaller than what we have been holding on in this second accumulator variable. So we are going to come up with a number. So then let's make an assumption. Looking at the list, we're going to guess that there's nothing that is greater than, say, 99,999, right? So this is going to be the value that we are comparing against, right? So let's begin with here. So now we are going to not having the searched item, but instead we are going to say, hold on, so let's take a look at this particular item, and we are going to see if it is actually smaller than our smallest item so far. If that is the case, I'm going to update the winner with the index of the winner, but at the same time I need to update now the smallest item I found is this item that I'm looking for. So list of numbers and at this location, right? So I use two accumulator variables. One, I store the location. Two, I store the current smallest number. But as you can see, once I go through the entire list, once this for loop is finished, then I'm going to store the index of the smallest item and also the value of the smallest item. So I'm gonna remove this and I'm gonna print the following. So the smallest item is at, and I'm gonna print out to the index, so tracked index. And I'm gonna print one more thing, which is what is the smallest number. The smallest number is, and right now I'm going to print the indexed number in the list. So I'm going to use that number, or we can simply use the index. But here, since I already have the second accumulator variable, I'm going to use this over here. Right. So let's give it a run. So you can see that now it's going to tell me that the smallest number is 1, which is what we expect because it is actually the smallest value in our list. And you can see that our tracked index is actually telling us the correct answer because we have the last item, which is with the index 11. Right. So in summary, the accumulator pattern allows us to calculate, count, and even find things. And the key components of this pattern include an accumulator variable that starts with a certain value, a loop that goes through the list, and the action of accumulating or setting things to the accumulator variable. I hope you learned something useful in this video, and if you enjoyed this video, please like, subscribe, and share it with your friends. Hope to see you again soon. Bye.